All right, so higher order functions are basically functions that either consume a function or return a function or both. So functions that operate on other functions either by taking them as arguments or by returning them are called higher order functions. So we can have a function that is add, which is basically the function takes in two numbers, number one, number two, and the answer is basically the first number plus the second number. Multiply is structured similarly, and it returns in the same manner. It's just multiplication instead of addition. And then we could have a function called arithmetic or uh, calculator, and then it's taking in two numbers, but then it's also taking in a calculation uh, uh, variable here or parameter, and that could be any number of things. But in our case, we're going to feed it in as a function, and then we can see let answer basically be calculation num1 num2. So arithmetic doesn't know exactly if it's going to be doing addition. It doesn't know if it's going to be doing subtraction, multiplication, anything like that until it actually gets its hand on the calc parameter. And this is a very common uh, way of organizing code. Like this is when we're starting to look into getting into like object-oriented programming and methods or functions calling other functions around the program to accomplish tasks. And so if we did arithmetic 2 and 3 and add, that means that basically this calc right here inside arithmetic would turn to add, and then we would be returning an answer that is addition, right? And so that would be the output. And the actual return is this method, but for us, it would resolve into the two numbers that we had, 2 and 3. So we would only ever see 5 as the return value. Functions that operate on, or I'm sorry, Y, want to reduce the complexity of each function. So this kind of goes back to when we start looking at solid code and single responsibility, and keeping things in a orderly manner and trying to keep things as small as possible. And that's pretty much it for the slides. Let's go ahead and take a look at what this looks like in Replit. Sorry, just 1 second here. I'm gonna mute myself and chase some cats away from a box that they're destroying right behind me. I don't know if you guys can hear it, but it's all I can hear is them. 1 sec. Sorry about that. My wife is from Germany, and her mom just sent us our Christmas packages. So we have these two giant DHL boxes that they smell like whatever they smell like, but the cats have been like all over them for the last day.
Nice.
Okay, so go ahead.
Oh, no, nothing. Just said nice.
Okay, so let's go ahead and let me open up a new one here. All right, and so we're going to take a look at some higher order functions. Right, and so this is, I could basically build this out in lots of different ways. So I could say, right? And could say choice. And I could come in here and I could build a like a switch statement where basically like if I put in a choice of, so let's say that I wanted to add 3 and 4 and then just say choice 1 and then build a switch statement where choice 1 is addition, choice 2 is multiplication, right? And we could keep going, right? So choice 5, like floor division, and so on and so forth. Choice 6, modulo. So all these different things. And what happens is that as I build all of these out, this method could end up being 30, 40, 50 lines long, right? And then it kind of becomes a mess. And if we're not, and I mean, it becomes even more of a mess if we decide to leave comments in here for which what each of these are. And also we're then kind of taking the choice of addition, subtraction, multiplication, and we're forcing people to remember that, well, if I want addition, I need to plug the number 1 in there. If it's multiplication, I need the number 2. And so this gets really messy really quick. And what we'd prefer to do is something along the lines of basically what we saw in the example in the slide. So where we return calc and then just num1, num2, right? And so now this is all that this method needs to know and needs to remember. What are you yelling at me about? Whoops. Go. So, and what happens is, so if I call calculator now, right, I need to give it a number, and then I need to be able to provide some sort of a calculation. I don't have anything written yet, so, but I can do that. Let's see. Feeding it in. Yep, okay. So I don't want to, so you can pass in a method and you can pass, or a function, and you can pass it to other functions, and this will not do anything, right? Like you're just passing in the code for the method. And I had in error put these parentheses on here. When you put the parentheses in, that is calling it. So when the computer comes in and it's scanning through here and it hits line 7, it doesn't actually call add. It just knows that it has add. If I put these parentheses here, then it'll try and call add as soon as it gets to line 7. And basically it's going to cause an issue because I don't have anything plugged in here. And so I'd have to keep going, and I don't need the duplication there. So I just want to pass in the method itself without actually calling it at this point in time. So now I can write add. All right, and now put that on there, we should be good. So right, and we get the number 7. And so what happens is when I come down here and I say calculator 3, 4, and add, what happens is up here, this becomes 3, this becomes 4, and this becomes add, right? And then so down in here, it would look like this, right? And so, and then we're returning out. And this is all a higher order function is that it's basically taking in another method and then it's spitting it out the end. Any specific questions about this?
Negative. We are tracking right now.
All right. Well, one person's tracking. Any questions from anyone else?
Well, hold up. So usually I don't know the term for it is like not order of operations, but the order in which you want to code something is the way you want the computer to read it. So would you not have add before the calculator function?
No, because as long as because nothing happens until we get down here, right? So I may, and again, my grasp, because I don't work every day in JavaScript, my grasp of hoisting isn't the best. But see, because as long as it's coming in before my call, so like my call to action right here, then we're good. Now it's saying cannot access add before initialization, right? Because now my console.log is, and my function call is above the method, right? So for here, it shouldn't matter this way either, but we'll double check because, right, so this is good. So as long as it's before I actually call on it, because right here, these are basically just bits of code that are being stored in memory. Nothing's happening with them. The computer isn't trying to do anything with them. They're just holding on to them. Because it's the same thing. Like if I get rid of this line and I hit run, nothing happens, right? I mean, the computer still read all of the code, stuck it all in memory and said, okay, add is equal to this and calculator is equal to this, and I'm ready to use them, but then we never tell it to use them, so the program shuts down and then the memory is cleared out. All right, so as long as everything is declared before I try and act on it, then, because it should be the same issue if I do this. All right, so now cannot access calculator, and usually they go in order, so it stops as soon as it hits the first one. So it's not like it hits the first error and then it keeps looking for another one. All right, so can't find the calculator. Oh, well, I see my calculator is not where it's supposed to be. So I fix it, I put it up here, we run it. Okay, well, add's not in the right place either. Grab it, snag it, throw it right here. Right, and same thing. So if I come in here now and I do const subtract, and also I'm calling these num1, num2 across the board. So I could call this like int, or well, I don't want to call it int. Sorry, that's protected. So, but I could call this num3 and num4. And so I could say return num3 minus num4, right? And so now I can come down here and say console.log calculator, and I could say 10, 5, and subtract, right? And if I run this, right, I get 5. So I did 10 less 5. And so again, and I think for clarity's sake, like I would still leave these as num1, num2, but you don't have to. I mean, this can be chicken and this can be pizza here. And again, bad naming doesn't help us determine what's going on here, but parameter names are only, and this can get very confusing when we start passing things around, is with what happens to different things. So right now, if I change this back to num3 and num4, right? So when I call calculator and put in 10 and 5, this basically becomes 10 come on. 10, this one's 5, and this one's now subtract, right? And so down here, what happens is this becomes subtract 10 and 5, right? So num1 and num2 are just the parameters that are getting passed in to this method, right? So right now, num1 is 10 and num2 is 5. Well, then I come to subtract, and then when I come down here, this is also 10, and this is also 5, right? And then down here, this turns into 10 minus 5. Right. And so even though the names are different, so like what the parameters are called, and again, this is just I would not do this in real life. This is just to kind of demonstrate what's going on here. But like these number, like it's not actually num3 and num4, it's 10 and 5, right? And these are just variable representatives of what you're feeding in when you actually call the method. Right, and for clarity, I'll change this back here. Oh, 2 and num2. All right, and so now you can see like I call calculator 10, 5, subtract, 10, 5, and subtract come in as num1, num2, and calc. Right, this becomes subtract. Sorry, figure this out by now. And then 10 and 5 in here. And then again, same thing down here. This turns into 10 and 5. I return 10 minus 5. And then this returns same thing. And that's what we have at the end of the day is that 5. Right. And you can see like basically like if I take this and again, throw this up here, if I throw this above the subtract, I should error out on subtract, right? Because I still need this. Oh, let's see here. What else do we want to cover with these guys? Right, and so we could take another one. Sorry, I keep writing def. I've been writing Ruby all day today, so. So, and also just like a quick thing to toss out there. So when you do like an ES6, a fat arrow function, you can see, so if you have no or more than one parameters going in, you need to have the parens. So like if I said name, age, I'd have to have it, or if I have none, then I have to have it. But if I just have one, I don't need to have the parens there. So, oh, let's see here. Yeah, it's a little too convoluted. So I'll leave that here for that. Any other questions with the and kind of what we're looking at with the higher order functions? And there's ways to do things without doing the higher order functions. But as software becomes increasingly more complicated, like as you're writing more and more lines of code and the program gets bigger, you're more and more likely to see examples of this happening in the code base.
All right, got it.
Okay, so let's see. I guess we can hop into our first challenge, which again, I will go ahead and lead, and then we will go into a group challenge or take a quick break, and then we'll go into the group challenge. And you'll do a similar one, and we'll come back and tackle another one. So this one is my colleagues, or I'm sorry, my coworkers. So you're given an input, or you are given input is a, no, you're given, come on guys. You're given input as a nested array of colleagues. Within the nested array, there are your colleagues' titles and characteristic of them. Write a function that console.logs the colleague's name, title, and their characteristic, and then returns true. Right. So it looks like, and they're nice enough to copy that over for me. So it looks like I'm going to have one parameter, and it's going to be a nested array of strings. Right. So this just makes it a little bit more difficult. It doesn't necessarily make it practical. Why you would have the double nesting here, kind of the career path and a character, like a personality trait. Don't do it. Just part of the challenge. Doesn't always have to make sense. It just has to make it harder. So, and we want to take output and basically console.log these, basically put everything into a sentence, and then just return true. So that at least makes it easy, because I know I can put true down here and return true, and I'm passing at least part of this. So okay, so how would I go about figuring out how to get to each of these different things that I'm looking for? Anyone want to take a stab at that?
You could loop through them using length for both the whole array and then the arrays within the array.
Okay, so I will need a loop, so that's good. Right, but do we know exactly where everything is at? So if I say, hey, can you tell me what the location of Jim's job is in colleague data?
No.
Okay, right. So off the top of the head, we know how to get it, but I mean, off the top of the head, it's a tough one. So what I would say is before we even loop is let's kind of explore where we're at with this, right? So I've got colleague data, and if I run this, I can console.log the entire thing, right? And so if I do colleague data 0, okay, so now I've got the first employee, right? So let's do this. All right, so there's the first employee. And then if I do, right, now I get to Stacy. Right, and now it ends up getting a little bit trickier because I've been just dealing with 0 so far, but now if I want to see what happens next, I know that this is a additional nested layer here. So I could do this, right? And that gives me both the right? And so now I know that if I come in here, right, IT person, right? And so for this, now now I know exactly what I'm looking for. And I don't need this. I won't really need this. I will need their name, and I don't need this. So these are basically the 3 things that I need to be able to assemble the string that I want to. Okay, and then, so now I can write my for loop. And so remember, down here, it's colleague data, but up here, the parameter is colleagues. So I don't want to do colleague data.length. I would just want to do colleagues.length. So remember, backticks for string literal. And let's see here. So just grab this. And we know that we don't need the actual name. We need this. And so this, I can also tell you right now, if I do this way, this works, or it should work at least, I would hope. Right. So, and again, we've got some extra stuff in here, but because I've got these console.logs, just clean all this up here real quick. Oops. And sorry, anyone see what I did wrong?
I guess you added in an extra console log.
I did add an extra console log right here, which I think was, oh, because I grabbed the whole line. But besides that, what else did I do wrong here? What does my output say?
Oh yeah, return true.
Well, return true, but where's Jim, Jenny, and Corey? Right? I just returned Stacy is an IT person each of these 4 times, right? So that isn't necessarily what I'm looking for, right? So I believe what I'm looking for is to change this to I, and now the IT, it'll say IT person and super smart, but now I'm at least getting the different names, right? And so now I can come in here, right? Now I've got their careers, and then lastly here, added into this one, right? And now we've got the answer we're looking for. And also, quite honestly, in something like this, where these are very messy, what I'd probably be looking at doing is dragging these out into a variable, because this doesn't tell me anything, right? When I come in here and I look at this code, I just see colleague data, colleague data, colleague data. And even though I set it colleague data, I went and then did colleagues, because I was up here and this is at the global scope, and this should not be colleague data, it should be colleagues. So trick question to what I did wrong. I did a bunch of stuff wrong. Right, so now it should still work. So it still works. And then what I look at doing is take this and pull this out, and let's call this first name. Got to do it inside the loop. Right. And so now this is a lot easier to read than just trying to read these, basically like accessing the nested array through here. Right. And we still get the same results, but now once this information is no longer present on the screen, I can come in here and I can look at this method and I know, okay, well, I need the first name, I need the job title, and I need the personality trait. And that makes it a lot easier to troubleshoot if I come in here and I run the code and I see IT person is the IT person, salesperson is the salesperson, right? Because now I come back here and I say, this is supposed to be the first name, right? It's not just a nested array access through box notation. And so just that visual cue makes it that much easier to help debug it later down the road. And what did I do? Say grab the character because I inserted that. There we go. All right. And so any questions on what I did or kind of like what my thought process was when I was solving this one? Okay. So, and the other thing I would throw out is that you would, well, there's lots of different ways that you could see this. This particular way, like everything's stored in an array, we could have a similar problem where we say, right, and this would be, in my opinion, a much better way to store this data. Right, and then we could just add verse doing, this is more
Right.
just to solve a problem, right? Like we're illustrating how to dig through nested arrays.
Okay.
But what would be more likely is you would see maybe an array of nested employee objects, right? And do this. And so then same thing.
It's a lot cleaner.
Yeah, and it's also, it's just, I mean, and it's cleaner to access as well. So one sec here. So it's easier to access, and it's also easier to read when you're looking at the way that the data itself is stored. Right. So I can come in here and basically give me better spacing on this. This is driving me nuts. All right. And so here is something where, like, now instead of just seeing like a bunch of information smashed in together, like it takes up a little bit more space, but like I can see, okay, name Stacy, title IT person, personality trait super smart. And so we could do, right, and then, so here's the information. And so now I could do, right, like the same thing basically. Right, so there's Stacy, but now instead of having to access a bunch of numbers right now, I could say .name. All right, and so reading this, even furthermore, when I'm going to look for information, so I can say first name, but then when I look at this doesn't help me or tell me where I'm actually reaching or like what I'm actually touching. It's just a index location, again, inside this data structure. Versus here, like, and I've got that, and we could do the same thing. So we could do a for loop again. So let I instead of that 0, just do that. Right, and there's Stacy and Jim. Right, and now could do the same thing again, and it also it makes it a little bit easier. Again, colleague data is like a really long name, so I would still probably take it out of here, but you don't run into that same issue. Right, like this even here is still way more readable than when all three of these things were crammed in the same thing. Right, so Jim is a salesperson, Stacy is an IT person, and so these are both two ways to store data, and neither of them are technically wrong, but one of them makes this easier on yourself and anyone else that's trying to take a look at your code. So any questions about this and kind of what I did here and how it's similar to what we had going on up here?
Is there a plus side to doing it the second way as far as space is concerned, or does it make it worse?
So, I mean, it takes up more lines, right? Like this takes up what, 5 lines, 6 lines, and it has 4 people in it, right? Like right now I'm at basically 11 or 12 lines and I've only got 2 people. So it takes up more space, but it's honestly, it's good space and it's readable space. So like if you were to come in and look at this, and especially if let's say you worked at a place with 1,000 employees, right? Like this is going to take up way more space. But could you imagine if you were trying to pick through and find someone that was just 1,000 lines that looked exactly like this?
Oh, no.
Right?
Yeah, that's basically my question, is just to see, like, in the real world, which one would be more preferred, or if there are any. And I mean, understandably, the second version is going to be a little bit more space. It's going to take up more space. But as far as like the program running, is that going to be an issue too, or?
No, the program doesn't care per se. Like technically you could write a faster program if everything was in an array because it has a fixed index position. So the computer knows how to get there quicker than here, where like, because, and this is like the issue, right? Is that right now inside this colleague data, right? Like, I mean, if we pulled all that up to one line, Stacy is at the 0 index position, right? And this is at the 1 index. So Stacy is employee 0. And if you know that Stacy's always going to be employee 0, then it makes it much quicker to get to exactly where you're going with her, right? Versus this, the computer doesn't like differentiate between this in this, right? Like there's no alphabetical order. It doesn't matter where they fall in here. Like there is no guaranteed order inside of an object, right? They don't have index positions. And so they do have an index position inside the fact that like these objects are nested inside an array. So this one is in the 0 position and this one is in the 1 position inside that array, but there is no index position within the objects themselves. But this would be the preferred way of storing this data, like in a real world application. Right?
Yeah, I
Like,
could totally see that, because
so
I got lost that first round, but the second round was way easier because I was just like it flows a lot more.
yeah, and like I mean, if I was like I said, like if I was working in my day job and I was expecting a chunk of information to come forward about an employee and it showed up in an array, I'd be like, who did this? Like that would be like my immediate first thought, like who did this to me? Like I would almost always expect it to show up in this type of format.
Yeah, to me, the person who loves Excel would do it the first way.
Yep, and there is a unlearning with like for people that are like is that are like super heavy into Excel, and Excel can do some crazy powerful things, and Excel can do some crazy powerful things without having to write lines of code. But it's harder to get as customized with Excel as you will in with being able to write your own software program. And so, but there's definitely it's just a different tool, right? And some jobs require spreadsheets, other jobs require software. They're like an algorithm, but it's like people that have worked with Excel for years, and like maybe even a little bit of like VBA, Visual Basic for application, dabbled in some macros. There's unlearning that you have to do to start dealing with JavaScript.
A quick question about some coding. Is SQL kind of like a bridge between Excel and coding?
Not really. SQL is also it's only similar to Excel in and of the fact that uh, basically SQL is a language that you use to manipulate a database, right? It's what you use to retrieve information out of a database. So like if you're used to filtering or sorting in Excel, like it may kind of feel the same. Like if I do the SQL command, it's the same thing as like reaching into an Excel table and pulling out the information I need with a filter function. But it's and understanding how they work is uh, important. But like with SQL, it's like they can get like they go from very basic to getting like you can really stack um, the commands in with each other to the point where like there is a whole career of being a DBA, a database administrator, who basically help maintain the health of the database and also will help people um, basically find data, right? So this tutorial looks at how we can use select statements within select statements to perform more complex queries. And so how do you write this to get to like the right answer? And so here is some raw SQL, and like here is the result from the database that you get, and show what the answer should be. It's this. So like there's some things that have to be changed with this, and there's little tutorials, but definitely learning how to use SQL, uh, thinking like a database will, or thinking like a spreadsheet will help you learn or grasp SQL, but it is a different skill set. Right? And there's like SQL Zoo. I think they touch on this in Code Platoon still, or I don't know if they use a different resource. This is what we used when we went through. Um, but you're basically just going to write a query that you can ping off your database, and the database will return information. Right. And so like this is select name from world where continent, select continent from world where name Brazil. So basically what this is saying is that we're looking for the like the name field um, like from anywhere in the world on the continent table, right? So there's your continent equal, and so yeah, it's like they can get crazy. also the other thing is too, is that you don't spend a ton of time learning SQL at Code Platoon. Like you touch it, like I think you have 3 or 4 days of it. But as soon as you get the grasp of how SQL works and the underlying, you will actually then learn Django, which is a Python web framework that you actually will write Python code, and Django interprets the Python code into SQL for you and reaches into the database and then pulls it out and gives you information that looks like this, where, oops, yeah, not in the notes. Where is this one? Will look like this when it comes out, right? And it presents you the information, and then you'll start to dig through the information so you can access it and display it on a web page somewhere for a user to consume.
Cool. I was wondering about that because I saw that we touch on SQL a little bit, so that's good to know.
Yeah. So yeah, and it's SQL or SQL, either one. I mean, people throw both around. SQL is actually, it used to be spelled SEQUL, and then they were sued by a British like arms manufacturer or aircraft manufacturer because they had already patented the name SQL. And so they just dropped the E out of it, and it is SQL, but everyone still calls it SQL. So that happened like back in the 60s or 70s or something like that. All right, so done with that one. Is there any other questions that I can answer about this before we take a quick break here and then come back, and then we'll split you out into 2 groups. It looks like there's 8 people, so we can do 2 groups of 4, and we'll tackle the next challenge in the groups. Okay, so let me go ahead and pause the recording.
All right, so we handled the is prime challenge. And so let's go ahead and cover a couple of different things here. So right now, as we want to do it, basically a prime number is a positive integer with no divisors besides itself and 1. Cannot be divided without a remainder by any number besides itself and 1. Write a function to check whether a given positive integer greater than 1 is prime or not. Right, so greater than 1, so we know we don't have to really solve for 0. If I take a look here and I search for prime numbers, right, so 2, 3, 5, 7, and 11. Right, 2 throws a lot of people off because I think kind of the default is to say, well, if it's even, it can't be prime, but 2 is unique because it can only be divided by 2 and by 1 and still come out evenly, just because there's no other numbers between it. So 2, 3, 5, 7, and 11. Now, so what we look at here is with the prime numbers, I know that there's a couple of shortcuts that we can take. So I can say if num is triple equal to 2, right? And I'll put it all on one line here. So we can return true. We know that it's a prime number, right? And the other thing we can do to save a little bit of time is we don't care how large the number is. If it's evenly divisible by 2, then we know that it's a prime number. Right, and so we need to take a look at the modulo operator here, because that's what gives us remainders. So it basically, if the number modulo 2 has a remainder of 0, we know it's an even number, and we know at that point that it is going to not be a prime number. Now, the other way, or the kind of the last way and the main way that we're going to check here is if we basically have to go through and divide the number by every number between 1 and itself. We know that it can be evenly divisible by 1. Every number can, so we can skip 1. So what we'd be looking at is we'd be looking at a for loop, and we'd probably start counting at 2, right? And I would say we could start counting at 3, but then I think that would take the number 4 and return that as a prime number. So we need to start counting at number 2. So we can say for let I equal 2, I less than the number that we're counting against, and we're going to do every single number, right? And so we can just reuse the same if statement that we had up here, and we're just going to move that into the loop. And instead of doing modulo 2, we're going to do it as modulo I. So kind of the gotcha that I was throwing out to the groups was the number 49, because it's an odd number. And if you just run it against this, in 49 modulo 2 has a remainder of 1, so this would not return false, and it would say that 49 is a prime number. However, we know that 49 isn't a prime number, and we can do console.log, do this. Sorry, I have to take this and let's do this because we're going to move it to multi-line. And let's console.log that. And then if it makes it through that without basically returning a false and punching out, we can come down here to the bottom of our method, and the last thing we'll do is return true. If we make it all the way down to this point, it will be a prime number. And so we can run this. So 49 is evenly divisible by 7. Right. So we could also take another large prime number, right? So, or non-prime number. So we could say like 81, which is a odd number, but 9 times 9 is 81, right? Oh, so I'm sorry, before we even get to that, it's evenly divisible by 3. So 3 times 27 is also 81. So we're just punching out at the first one that we hit. We could write this so that basically every time it hits something that's evenly divisible by I, that we then, we could do it this way. So we could say, right, so now every time we come through, if it is, if I can go into num evenly, then we'll actually just push I into this, and then we'll check the length of it here at the end. So if it's 0, if we know that it's empty, we know that basically the number is a prime number. If it's not empty and there's at least one thing in there, we'll go ahead and console.log it so we can see everything that is evenly divisible by, and then we'll return false. And I've got a spelling error somewhere, which is why Oh boy, even divisors as ors. There we go. So 49 is evenly divided by 7, and 81 is evenly divisible by 3, 9, and 27. Right, and we could, all right, and so it's a little improvement on over what they asked for in this, but this gives us a better idea of what we're dealing with, right? And so does everything make a little bit more sense when I kind of walk through and like what the thought process was with this? Any questions that I can answer? Everyone's just super eager to get into the next challenge. Okay, so let's go ahead and take a look at this next challenge. So it's 7:56 here. I'm going to talk for a little bit, and I'm going to get you guys into your groups by about 8, and then I'm going to give you 20 minutes straight to work on this. I'm not going to check in with you this time. I'm going to pull everyone back into the room after 20 minutes, and we'll talk about what we've got, and then I'll walk through the explanation again. And that way, because if we do it that way, I think we'll have time to kind of get 2 more challenges in for the night. All right, so instructions: write a function that takes in an array of letters represented by grades for a semester. Example, A plus, C minus, B plus, A, C plus, and return the cumulative GPA for the semester. And here is the GPA letter grade. So what I'm going to say is that you will definitely need a data structure that works off of key value pairs to tackle this problem. All right. And what I would say is, before you go through the whole thing, like going all the way through F and adding all the entries, maybe just try and get the first one passing, and then you only need basically A plus through C, and don't worry about these ones yet. And then once you get that first one passing, then you can add in the extra, like take the effort to add in the extra letter grades. All right, so any questions on this one before I push you back out into the breakout rooms? All right, here we go. All right, so we're recording again. This last challenge was, what's my GPA? And I just kind of built out the structure here of the object that we need. And Diz, I think this is what you were talking about with the fact that like there's a special character in here, so we had to put it in quotes instead of just leaving it as like something like that, right?
That's right.
Yeah, and so anytime there is like a space or something along those lines, you end up having to put it in quotes to get it to work. The other common fix is you'll see things put in snake case, right, as a key just to get rid of that space, or you can do it as camel case. But we'll go ahead and change this back to an A plus. So what I would throw out with this one is that, just kind of like the other ones that we tackled, is if you don't know exactly how to get here, is that you get here step by step, right? So if I know that I'm going to need something to hold my GPA, so I'm just going to go ahead and say this, and that'll kind of be my placeholder, and that's what I'm going to return out here down at the bottom. And I know that because I'm working with an array of grades, that I'm going to need a for loop to go ahead and access each of the index position grades. I'm going to say for let I equal 0, I less than R of grades dot length I plus plus. All right. So if I want to see my grades here, so I can do this, we'll do council.log R grades, and to get the each of those, I should just be able to do box notation here. All right, so A plus C plus B plus A minus C, A plus C plus B plus A minus and C. All right, now to get to a key, I know that I'm going to need to see or I'm going to use the box notation here. Now, the key that I want to look for is the A plus key to get at this 4.33. So what ended up happening is I end up taking this whole thing, and that ends up becoming the box notation for my grades, right? So now when I loop through here, I should just be, instead of seeing like A plus C plus, I should see 4.33 and then 2.33, right? And so those are my values from my keys. And so now I can take this out of the council.log and I can say GPA plus equals grades, right? And I know I need to return my GPA. And what this will do is this is going to give me the cumulative. And so it's still false. So if I do council.log GPA down here, right, 15.66 and 14.33. So what I actually need is the average of all of these grades. So what do I want to divide GPA by?
Grades.
R of grades, and then what property of R of grades am I looking for?
GPA.
Well, the length, right?
Oh.
So because if
Right,
I have
yeah.
5 scores in here, I want to, and I'm totaling them up, I then want to divide by 5, right? But the same thing is if I add a 6 score in here, right, then I need to be able to divide by the length of 6 to make sure that I'm getting the average each time. And so now,
Which encompasses all of it, right?
yep, yeah. So
Okay.
like R of grades that length should be 5 for both of these, right? So
Okay.
I'm then taking my total GPA and I'm dividing it by 5. But see, the same thing is if I add another C in here,
It would include
right,
it.
it automatically includes it. All right, and so then it becomes dynamic. So it doesn't matter if I have 100 grades in here, I'm still always going to get the GPA, the average of it. All right. Any questions about the steps that I took to solve this one? Okay, so let's see here. This one. Now, let's take a look at this one. All right, so this is the car trip challenge. And so with the other stuff, we were going into arrays. This time, we're going to need to look at manipulating some data inside of a object. And then it looks like there's a nested array inside the object. So we need to write a function that takes in a car object in the form of people, miles, spare tires used. So people, miles, spare tires used, and a number of miles driven as an integer. Update, you know what? Actually, let's do, I think this one's a little bit simpler. So let's do this one first, and then we can lead off with the other one on Wednesday. So let's go ahead and do the current grade one. So write a method that takes in a student object with attributes GPA as a number and a grade level as a number, as well as an integer representing the change in their GPA. This method should update the student's GPA to include the change and increase their grade level by 1 year, and should return the updated student object. All right, so basically what we're going to do is increment the grade level by 1, and then apply the change in the GPA that could be positive or negative. Oop, careful, someone's not muted. Into the GPA. So like with the 0.3 here, after that they'd be in grade 11 with a GPA of 2.8, GPA of 2.8. And then this one starting off in grade 6, GPA of 4.0, had a rough year, so a negative 0.6. So after the methods ran, that would spit out a grade of, they're in grade level 7 and their GPA is now 3.4. All right, any questions that you have for me on this one before I open the breakout rooms back up? All right, so again, current grade is the challenge. Gonna do it the exact same way. I'll give you.
Go back and show the other solution. I mean, you went off the screen a little too fast for me. The other one, the previous one that we had.
This one?
Yeah.
Yes, any questions about it?
I was just trying to see how you did the for loop. That's all. Okay. So you just put the array of grades in the brackets.
Yes. Okay, so are you good, or any questions?
Yeah.
Yes, you're good?
Yeah.
Okay, cool. So I'm gonna go ahead and create the rooms. It looks like somebody had to drop. So there'll be a group of 3 and a group of 4. But I will pull everyone back in at 8:50, and I'll check in on you sometime just to see where your progress is at. But good luck on this next one, which again, we're doing the current grade. All right, so this one wasn't too terrible. This is the current grade challenge. Basically, we know that we are going to be taking in basically an object with a grade and a GPA, and then a floating number that is going to impact the GPA. We also have instructions that when we process this, we should add 1 to the grade. Right, so the end result ends up being pretty straightforward, right? So I can do console.log student, right? And there's my entire object, right? And so I know that I need to get to the grade, right? And so there's my grade. And so I can pop this out of the console.log, and I can say student.grade plus equals 1, right? And then let's go ahead and return our student object, right? So there's 11 and 7. So I know I've got that part done. Now, the other part, the GPA, is basically the same thing, just student.gpa. And we'll do, the improvement's going to come in as a variable. Do that. So there's the impact of our variables. So this one went from 2.5 to 2.8. This one dropped from 4.0 down to 3.4. Now, there are, and again, I popped into the rooms just to check to see where progress was at. I didn't say anything, but I did see some of the conversation around the box notation and the dot notation. And both of those are acceptable ways to access what's going on. So if I take, let's just comment this one out for right now. And there's that. So if I take this and I put that in quotes, right, I'm still getting it through here, right? And same thing, if I do box notation, if I don't put this in quotes, it'll blow up and say grade is not defined. Because what it's doing is instead of giving it a key that it's looking for as a string to match up with that, it's taking grade as a variable. Right, but as soon as we put these in quotes, we're back in business, right? And same thing for GPA. Now, where things get different, and again, so this is what I was talking about, is both grade and GPA are just single words, right? And now if I want grade point average, right, you can see like I'm already throwing errors, right? Comma expected. So I have to write this in quotes, right? And same thing here. If I now do, because I have to match this, and I don't believe I can do this, I'll give it a try, but I'm pretty sure it's going to yell at me and tell me that I have to do box notation here. Right, identifier expected, it's already thrown an error, so can't do that. But if I take that and throw it in here, notice how the error went away and I'm back in business, right? And we can see like this went from kind of like the white variable here to the green. And that is just that the quote's there, and that's how this particular system delineates between the two. So if it's just a single word, and again, I can get away around that if I do this, right? I can take this out now, do the same thing down here. Right, and then I'm back in business again. So like I said, you could see where it was throwing errors as it was doing it. The IDE was trying to stop me from doing it. And when in doubt, if one doesn't work, just try the other one, right? Until you get a solid grasp. Try it dot notation. If dot notation doesn't work, try bracket notation. If either of them doesn't work, then there's an error somewhere else. All right, so all in all, how did we feel about the challenges that we tackled tonight? It looked like everyone was making a little bit more progress through them without having to get like additional nudges. I'm gonna go ahead and turn off the recording here.